It is 10:30. Welcome to the Active Directory track. And I would like to warmly welcome Sean Metcalf. It's really a great pleasure and an honor to have you here in our Active Directory track. And we are excited, we will be excited about the journey. And we would like to go with you and your knowledge. So thank you very much, and the stage is yours.
Thank you. Good morning. This is Active Directory Security, The Journey, and I'm Sean Metcalf. This is kind of a fun title. It's fun for me because it means I can talk about pretty much whatever I want to. But we're gonna go through the journey of Active Directory, where we've been and where we're headed, potentially. So I'm Sean Metcalf, the founder of Trimark. We help organizations and companies better secure their Microsoft platform on-premise and in the cloud. Microsoft Certified Master in Active Directory. There's about 100 in the world, most of whom actually work for Microsoft. I don't. I've spoken at a number of conferences. Very happy to be here at Troopers in beautiful Heidelberg. The weather is very nice here, so I'm enjoying this. I'm a security consultant and a researcher, and I own and operate 80security.org, which hopefully many of you have been to before, where I post interesting information about Microsoft platform security. So the agenda, like I said, is this journey of Active Directory security. What is it? Where have we been? Where are we headed? What is the current state? And how can we make things better for our company, our organization, and our customers if we have consultants here? So we're going to start with the current state of Active Directory. So the good, the bad, and the ugly. And quite honestly, it's fairly ugly in a lot of cases. We start with the good. So there are some good things. There's a better awareness of the importance of AD. Obviously, there's an Active Directory security track here at Troopers. So there's awareness. There's more thorough testing of Active Directory security. So tools like Bloodhound and the focus on Active Directory at large means that the things that have gone and have been ignored over time are starting to be looked at and people are starting to dig into that. There's less domain admins. Well, overall there are. Maybe there used to be 200, now there's 70. That's better-ish, right? Less credentials and group policy preferences. We do security assessments for Active Directory, and we see less and less of these. There aren't none, which would be ideal, but it's much better than it has been. And ultimately, more of the local admin passwords are getting automatically changed via something like Microsoft Local Admin Password Solution or something else. Or organizations are starting to deploy this. So that's much better, because otherwise an attacker can get on one system, dump the local SAM, get those credentials, and then jump to another system. And in often cases, this can even occur if you have a build process that sets that same password for everything. And so even your non-domain joined systems may have the same local admin passwords as your domain joined systems. And PowerShell security has gotten much better in version 5 from 2, 3, 4, all the way up. Not everyone has deployed version 5 yet, but it's getting there. Now let's kind of look at the bad and the ugly. So obviously too many domain admins or Active Directory admins are still administering Active Directory from their standard workstation. Why is this bad? Well, think about how many people have admin rights or access to install or run code on that workstation. There's probably 1 to 20 agents on that workstation, from antivirus to patching to management, including a number of people that are typically in a help desk group or a local workstation admin group. They all have rights to these workstations. Compromise of that could then jump and pivot to the domain admin or Active Directory admin. And so privilege escalation from this regular user all the way up is still too easy. That's part of the reason why. There's a lot of legacy stuff that reduces the security. Mainframes still have a requirement of a certain password length. In environments that have to interoperate with mainframes, this means that the Active Directory user password length is probably going to be about 7 or 8 characters. It's not great. And still not enough PowerShell logging deployed. Even organizations that have deployed version 4 or version 5 still aren't necessarily configuring the logging on it, so they're not getting that additional detail of what's going on in PowerShell. And there's still too many blind spots. Why is this? There's not enough visibility of what's going on in Active Directory. Logging is not configured the way that it should be on domain controllers, in the environment to better understand and see what's going on in there. And the ugly. So in 2018, cybersecurity spending hit around $90 billion US. That's a lot of money. Does anyone feel it's gotten that much better? $90 billion worth? No, I don't think so. We still have attacks. I don't think the attack detection has gotten that much better. Certainly not $90 billion worth. And now we have more ransom and cryptoware, right? Crypto miners in organizations. A lot of attackers that have gone from encrypting things and saying we need a ransom to release this to let's just go ahead and mine Bitcoin or something else on there and make some money that way and just use those resources. And some organizations are realizing that their cloud resources are being used for this, which can result in a huge AWS bill that they weren't expecting. So where were we? How did we get to this point? Well, we were in an environment where Active Directory was being released in the year 2000, and the operating system is Windows Server or Windows 2000 Server. There were some key design decisions that were made in the late 90s for Active Directory, which persist to this day and really impact the security of the environment. Microsoft was extremely scared about replication because they weren't sure how that would actually work on a very big scale. So wherever possible, they minimized replication. They also said, this Kerberos thing looks pretty good. Let's take that and add some stuff to it and make it better, right? And so we have Kerberos in Active Directory as one of the key components or authentication methods in Active Directory. But we still have NTLM. Why? Because Microsoft wanted to ease this path from NT over to Active Directory, which meant there were a lot of these design decisions and configurations with compatibility as one of the overriding factors. And we still have that issue today. Microsoft's commitment to compatibility is one of the reasons why we have so many security issues in a Microsoft environment today. Unlike Apple that will kill off a feature in 2 months without much warning. But, you know, it's the give and the take. So what I call Active Directory version 2 or version 3 was really the 2003 timeframe. So Windows 2003 Server was deployed, got rolled out. All the way up, and each of these service packs that got released dramatically improved Active Directory reliability, replication capability, and the security components. And so we had a new attribute added called the last logon timestamp. A lot of you probably have used this to track when people have logged in to identify what users and computers are inactive, are stale. And then Microsoft said, well, the way that we did Kerberos Delegation when we released Active Directory was not ideal. Because it basically said, if you can delegate to this, then you can basically impersonate them to anything. So with constrained delegation, we're going to lock that down to just these Kerberos services here, which is much better than what it was. And I'll show you why in a little while. And then selective authentication for trust is a way to say, I trust you, but only this much. And so with the selective authentication, we can have a trust between two forests. And the users that are in this other forest that are connecting into our forest can only see and access what we want them to. Now, there is some overhead to that. There's actually quite a bit of overhead because that means I need to track what all of those users or all of those groups in the other forest actually need to access and then explicitly allow them to access it. So a lot of organizations deploy Active Directory. And then we go into this world where Microsoft says, all right, let's add some additional security. Let's add some better performance. 2008 R2 is really where Microsoft hit their stride with a lot of these features. We get the AD recycle bin, last interactive logon information so the user can actually see when they last logged on. Fine-grained password policies, which is great. Okay, so we recognize that we have mainframes in our environment and we're going to keep the Active Directory password policy default of 7 characters. Sure, why not? But now what we're going to do is create a fine-grained password policy and apply it to all admins and say your password has to be 16 characters. And we're going to say all the service accounts, your passwords have to be 25 characters. And they're going to change once a year or twice, every 2 years or something like that. Authentication mechanism insurance is this feature where we can say, this is how a person logged on. They used a smart card or they used a username and a password. And then we can define what they can access based on that information. Managed service accounts were Active Directory itself manages that password and then evolved into group managed service accounts. And Microsoft gave it the capability where it can manage that Kerberos service principal name or spin. And Microsoft said goodbye to DES finally and introduced AES as a Kerberos option. Great. So then we go forward into 2012 and 2012 R2, and Microsoft really focuses on how to protect these credentials. They recognize some mistakes in the way that they manage credentials, such as, for example, if you RDP'd into a server and you did what you needed to and then you logged off, that server would actually keep your credentials in memory, in LSAS, for ever, pretty much, until it reboots. Microsoft fixed a lot of that. And this shift in security focus to what is actually the problem, how do we fix this, how do we really lock down Windows to a better state, is shown in this protected users group, which I highly recommend that if you have this group available to you in your environment, which is when you have 2012 R2, that you add your admins to this, because this means that they have to authenticate via Kerberos AES, no NTLM, and there's no delegation allowed for those accounts. So they're well protected against Kerberos Delegation attacks. And their Kerberos authentication is going to be limited to 4 hours. So they have to re-auth on a regular basis, which means that if there's any group membership changes, they should be captured by that. And then finally, there's authentication policies and policy silos, which I don't recommend unless you plan on spending about a month trying to figure it out. Then in the 2016 Windows 10 timeframe, Microsoft said, you know what, this guy Benjamin Delpy might have a point with his Mimikatz thing, and maybe we need to change the way Windows is actually managing credentials. So if you've ever wondered if one person can really have an impact in how a massive software conglomerate actually does business, you can. Benjamin stuck with it and said, Microsoft, this doesn't make sense. Why are you doing this way? And after a number of years, Mimikatz is about 10 years old now, Microsoft said, yes, let's re-architect this. And they took what was the traditional Windows OS and put it into a VM, and then created a thing that's effectively a microkernel that they call Secure World or VSM, and then made that a VM too. And so they are at the same level. They are effectively peers on the system. And communication between the two is brokered through the hypervisor via RPC through these things called trustlets. And this whole concept is completely anti-Microsoft. It is this microkernel that no third party can interact with. No real drivers, no software's installed, there's no GUI, it's just this thing that's there. And that's where the credential secrets are actually stored, not in this regular Windows OS. So you can compromise the Windows OS, but you can't get into that microkernel because it's separated into its own environment. And so this is how Credential Guard and Remote Credential Guard and Device Guard, they leverage these features. And there's a lot of other security features that Windows 10 has now in 2016 that leverages this VSM, this secure world environment, to protect that information. But ultimately it comes down to a lot of minor changes, but some big impact as far as Recon and some of the others. Jared Haight and I did a class at DerbyCon training last year on Windows security, and we wanted to use Windows Server 2016. It makes sense, right? It's the latest OS. We used Windows 10. And while we were going through and building these labs, we realized that a number of the recon tools that we were using just weren't working. And we weren't getting the information that we wanted to. We had to change the labs about halfway through back to Windows 2012 R2 because a number of things just weren't working the way we would expect them to. So there's a number of changes under the hood to lock down and protect these ancient protocols that go back to the NT4 days, which really help the security of the platform. And now we have features such as shadow security principles, which are very interesting because it can effectively impersonate a security group in another forest. Expiring links, this is really great, where you have an admin group, but the admin group has a TTL, a time to live. And this means that any account that is placed in that group only lives there for a specific amount of time, a threshold. So 4 hours, 6 hours, whatever you have set that group TTL to be. After that time, that group is automatically removed. And what's great about this is Microsoft said, okay, that's fine, but they still have their Kerberos ticket. How do we fix that? So what happens is, if I'm in a group, or if I'm in 3 groups that have TTLs, one's 6 hours, one's 4 hours, one's 2 hours, what'll happen is the domain controller is going to look at that and say, okay, your Kerberos ticket is only good for 2 hours. After that, you have to re-auth. because at that point I'm going to be removed from that group that's at 2 hours. So this is in 2016 mode. So as you see, we're moving through to a much better place over time. This is one of the reasons why you really want to get your domain controllers up to a modern level of Windows. At least 2008 R2, preferably 2012 R2, and certainly looking to 2016. And it's also important to know that what you don't know can hurt. So like the predator hiding out in the jungle, there are permissions from systems and applications that have been deployed over years, maybe before you have been at the organization. Well, probably. And one fun thing about this is with Microsoft Exchange, it doesn't matter what Active Directory permissions a user has when managing Exchange. If the user is authorized via Exchange RBAC, the user can perform the action regardless of his or her Active Directory permissions. That's intriguing. Tell me more. All right, so how does this Exchange thing actually work? Well, there's a few new groups in Exchange that have been around since around the 2010 days. There's the Exchange Trusted Subsystem. This is like system in Exchange. Has full rights to all the Exchange components and configuration, container information, and Active Directory. And the members of this group are the Exchange servers. And one of the members, this group here, the Exchange Trusted Subsystem, is also a member of the Exchange Windows Permissions group. The Exchange Windows Permission group is this separate, completely isolated, let's say, for Exchange, this parallel security configuration, which is granted rights on users and computers, users and groups, and have modified rights to a number of attributes on those objects. So that way, Exchange goes, you know what, AD admin, you don't have to do anything. I've got this. I'm going to make sure that my Exchange admins have the rights they need to do their job. And then there's the organization management, which is kind of the domain admin of the Exchange world. So organization management has full rights in that Exchange org. Really, there shouldn't be anyone that's a member of this, but I usually find that there's often many more that need to be there. So what's interesting about this is if I'm an attacker and I compromise an Exchange server and I get system rights on that Exchange server, that system right on that Exchange server is a member of Exchange Trusted Subsystem. So now I own the Exchange org from that one server. But it's also a member of that Windows Permissions group, Exchange Windows Permission group. And so what that means is I have rights to a lot of other accounts and groups in that organization. Maybe even admin groups, because one of the things it's able to do is change group membership. And so what we have here is this Exchange rights and RBAC system where Exchange has extensive rights throughout Active Directory, modify rights on many objects, including users and groups, except those protected by admin SD holder. And this access is provided through these Exchange groups, through this separate system of permissions that is not obvious to Active Directory. You can scan Active Directory and look for any custom groups or users or anything else that has rights there. But if you're not also looking at the Exchange rights, you're missing a lot. And if you've migrated to Office 365, guess what? These permissions are still there if you've had Exchange. Because these permissions exist and persist from 2000 to 2003 to 2007 to 2010 to 2016. And over time, in the beginning, Microsoft said, let's just give Exchange all of these rights. And then over time, they've kind of pared that down in the 2010 timeframe. But they're still there. And it's not just Exchange. I mean, Microsoft SCCM is an interesting beast. Originally SMS, not text messaging. But the granular delegation within SCCM was difficult until around 2012. And so it has this role-based access breakout for desktops and servers, right? So we can manage our workstations and our servers, which makes sense because everyone only has two type. Oh, wait. No, there's also domain controllers, right? But there's no delegation or way to separate those out. So what does this mean? This means pretty much any organization that's using SCCM is also patching and managing domain controllers bundled in with servers or with workstations, which is problematic because that means if an attacker compromises an admin account for SCCM or SCCM itself, then they can compromise and install or run code on a domain controller. And it's not just these Microsoft tools. I mean, there's plenty of third-party products that have and require permissions from domain user rights to IAD object rights to system rights to full AD rights. So I went through and I looked at a bunch of different products and I was like, you know what? there's a pattern here. Every product seems to require pretty much the same rights, and it comes down to this pattern. I'm not sure if it becomes obvious to you, but it became obvious to me that pretty much every one of them wants domain admin. Why? Because it makes it easy. It makes it easy for the vendor when they're developing the product, when they're selling the product, post-sale support of the product. It's easier for the customer. Just everything works. But everything works for the attacker as well. And a lot of environments, they use the built-in groups for delegation, like account operators, server operators, et cetera, et cetera. But they don't always mean what they think they mean, and they often provide more rights than expected. And then they provide full control at the domain root, so that way it flows down to everything and everything just works, because let's just make it work, right? And the delegation tools in AD are very challenging to get right, because nobody really wants to have to look at this on every OU or every object and try to figure out what's going on. That's not fun. And it'd be very difficult to see or identify a mistake that was made here. I mean, like perhaps someone delegated domain computers to have full control on this OU, which would mean a compromise of any domain computer would have full rights on this OU and anything in it. That never happens, right? But it's very difficult to see something like that unless you run a tool that is scanning Active Directory for permissions or using something like Bloodhound, which does something similar. And the cloud isn't to be excluded. The cloud has some issues with this as well. Why? Because we have to integrate our on-prem environment with the cloud. So Active Directory provides our single sign-on services to these cloud services, and there's directory sync tools that sync information from our AD to cloud services. And most of these sync engines only require user rights. But this means that many organizations don't even know what kind of cloud sync is involved or occurring. Do you? I worked with an organization, and they went through and forced everyone to change their password. They're like, we're tired of this. People haven't changed their password in years. We're going to change all of them. And then someone complained, oh, well, this account that we were using, we're actually doing some sync to this cloud service. And IT said, what? And security said, what? No, you're not supposed to be doing that. And they're like, well, we got a user account, and we did it. No. I mean, the problem is that people don't really understand where that data is going. And if there's certain regulations that apply to your industry, your company, your country, your geographic location, synchronizing this data to a cloud service may put you at risk. Now there's Azure AD Connect, which is part of what you have to implement in order to go to Office 365 and leverage Exchange and all those cloud features. And so these are the standard feature set of Azure AD Connect, which I'm not going to go through all of them, but one of them is password synchronization, which is not really well named, Microsoft. This is actually taking a hash of the password hash for AD and putting that hash of the hash up in Azure AD. So that way users can log in directly to Azure AD without having to come back through your local AD and do something like federation. So what's interesting about this is even if you're not allowing or enabling this password synchronization, and when you set up Azure AD Connect synchronization, you just said express settings, you hit the easy button, so to speak. There's a couple of rights that are interesting here that are used for password sync. And so at DEF CON in July, I called this out, and I said, be aware that this account may have more rights than you think it does. It says for password sync. Well, there's an interesting tool that's a component of Mimikatz called DC Sync, where if you have the appropriate rights to sync a password, you basically tell the domain controller, please send me the password data for the default admin password, or the KerbTGT account, or any computer account, or pretty much everybody, because I like to have all the password hashes. And it will do that because I have the rights. So one of the things that you'll definitely want to do if you're working with Azure AD Connect and your company or the company you're working with says, well, no password sync, you want to make sure that you're using custom permissions and not setting that, at least not initially. Because one of the interesting things that came out of this a number of months after DEF CON towards the end of the year, Security Advisory 405-6318, Microsoft said, by the way, if you have this configured based on the standard configuration, so that express setting, this service account is created in the user's OU, and it has the ability to synchronize passwords. Well, account operators has default access to the user's OU and can control this account and change the password. It's a great reason not to use account operators, by the way. But to be aware of what kind of exposure these things potentially could give you. And so it's important to note how this password sync actually works. So about every 2 minutes, the synchronization agent on the Azure AD Connect server requests those stored passwords from the DC using the standard method. And it looks like this. So you have the domain controller. It goes to the Azure AD Connect server, which does a lot of crypto stuff to it, all of this up here, sends it up to Azure AD. That's pretty solid. The thing that we've seen is that organizations forget that this actually, at some point, has every password for every synchronized user in memory and is performing actions on those. So in environments where you have multiple forests, all of that password data is flowing through the Azure AD Connect server. So this is kind of like a super DC, because if I'm an attacker, I'm just going to go after this, because that's going to have what I need. Or I'm going to go after that special account that's used as a service account for that. So there's a few things you want to do. First of all, protect this like a domain controller, lock it down, firewall it off from the network, since it only needs to connect to Azure AD and your domain controllers. And only AD admins should ever really be allowed to log on or manage this. You can lock down that service account, its logon ability, just this server, and monitor that. And of course, keep the account operators group empty, because there's really no reason to have that open and accessible. But ultimately, in Active Directory, common issues persist today. We have this issue of groups being in groups, being in groups, being in groups, and then trying to follow that path makes it very difficult. There's a group that's in domain admins, and there's a group that's in that, and the person that is a member of that group isn't really sure what that group is for, so they add another group to it just to simplify stuff, right? Makes sense. Sure, let's simplify by adding more stuff to it. And then before you know it, people that aren't supposed to be domain admins are domain admins. And then we see organizations that still have the default domain controllers policy that looks similar to this, pretty much vanilla, the same as it ever was since the very beginning. Microsoft has not changed this policy since the early days of Active Directory, back when they were concerned about replication. And so in that default domain controllers policy are these standard user rights assignments. Now, I'm not expecting anyone to actually read this, but I recommend that you do look at your default domain controllers policy and that you look at the policies that apply to domain controllers, because they can go from basic to bad. Something like this, which looks pretty much exactly the same as the screenshot I just showed you, right? Especially those in the back. So let me help you out. So someone, for some reason, has added domain users to allow logon locally. Why? I don't know. We've seen this a few times in the past couple of years. We've also seen where it's been configured where someone can remotely shut down the domain controller, and domain users are in that. You know, just in case the admins are out of town and we need to do maintenance on the DC. Hey, can anybody in the company shut down the DC, please? Because we need to do that right now. I'm not really sure. Or this situation where you have allow logon through remote desktop service has server admins or some other group, but you know, anyone can log on locally. This means that server admins can actually RDP into the DCs, because yeah, why not? It's a server. Now, just the right shown here, allow logon locally, does not allow them to connect over the network to it via RDP. They need this other right. But if they had access to virtual client or the server itself, because it was sitting right over here, then anyone could log on to it. And then the other one that's interesting is managing account auditing and security log. So Exchange typically requires this, and sometimes there's other service accounts or groups that are added to this. But the thing to understand about this, and the one thing I want to point out as a takeaway, is clear the security log. So any member that has this right on the domain controller can clear the domain controller security log whenever they want to. So be very careful of how that's configured. And I mentioned delegation earlier. There is a user rights assignment on domain controllers called Enable Computer and User Accounts to be Trusted for Delegation. So this is very much that Kerberos Delegation configuration. And Kerberos Delegation, that's a little confusing. Let's call it impersonation. So basically, if you're a goat and you want to be a duck, you could just impersonate the duck. It's Thursday. What animal do you want to be? So the way that Kerberos works with this double hop issue is you have a user that connects to this web server. You have a database server behind this web server. And using standard Kerberos, the user connects to that web server, and the web server performs the update on the database server as the web server. Well, that's not great, because that means every user who authenticates to the web server is going to update that data as the web server. So every single update to that database server is the web server. So through Kerberos Delegation, we can say, web server, you can impersonate users, and you can make those changes on the database as that user. That sounds very useful. As I mentioned, in the early days of Active Directory, there was this thing called Unconstrained Delegation, which we can find using this lengthy PowerShell command. But Unconstrained Delegation means that when that web server receives that user's service ticket, that web server is basically allowed to impersonate that user to any Kerberos service on the network. That seems less than ideal. So this is what the configuration looks like on the computer account. Trust the computer for delegation to any service, Kerberos only. So I dug into this and spoke about it at Black Hat a couple years ago and pointed out how the Kerberos Flow works for this, because it seemed kind of vague. And even the documentation didn't really dig into what it actually meant. So you have your standard Kerberos auth where you go, I'm Sean, here you go, domain controller, this is my proof of identity, this is who I am. Okay, domain controller says, here's your TGT or your authentication ticket. Use this for further requests for a service ticket. Sure. So then I take that back and say, domain controller, I want to talk to this application server over here. The domain controller looks up that application server and says, unconstrained delegation. What I'm going to do is take that TGT, your authentication ticket that proves who you are, to any domain controller in order for you to get that service ticket. I'm going to put that in that service ticket that you are then going to provide to that application server. That application server can now impersonate me whenever it wants to any Kerberos service on the entire network. So as an attacker, if I compromise the server, all I need to do is to get a domain admin or someone with rights that I want to connect to this server on any Kerberos service. Like, I don't know, a file share? Would any domain admin be concerned about connecting to a file share on a server on the network? Probably not. There's a number of ways to get them to do that, which I won't get into here. But once they connect to that, their TGT, that authentication ticket, is now in memory on that server. An attacker can extract that, reuse that using Mimikatz or something else, and then connect to a domain controller and dump the Kerb TGT or whatever really they want to. Just because they compromised a server that had unconstrained delegation configured, and they got someone with rights to connect to any Kerberos service on it. So there's constrained delegation, which is much better, right? Because what we'll do here is we'll say, all right, the delegation is only going to work on this server to these specific services on these specific servers. Much, much better, right? But of course, if the attacker owns a service account, they can impersonate the user to specific service on a server, but it's better than unconstrained delegation. Microsoft also added something else in this time of constrained delegation that they call protocol transition. I call this magic. Let's see what happens with protocol transition. This enables this server or service account to impersonate anybody on the network to a Kerberos service that's defined here without any prior authentication or proof of authentication to the domain controller. So here's how this works. I'm the server that's configured with protocol transition. I say domain controller, everybody in this room authenticated to me, give me delegation tickets to these services. And the domain controller checks, sees that I have those rights, and magically gives it to me. Phew. So you didn't know you were going to see a magic show today. But that's how it works. It's just that easy. And so anyone that has this right here on a domain controller, like trusty McService account, has the ability to configure delegation and has control over this. Can configure protocol transition or Kerberos magic, and then basically just say that admins have authenticated. So something that's pretty interesting about this is at DerbyCon a couple years ago, I talked about how you could use a silver ticket for an LDAP service on a domain controller to then do DC sync. So what does this mean? This means that if I have a ticket that says I'm a domain admin or someone with rights to do a DC sync to the LDAP service on a domain controller, that means that I can DC sync and pull those credentials from Active Directory. So I wondered, what if I could add some magic to this? So I did. And so what ends up happening is we have a service account here which has the ability, just like that MSOL Azure AD Connect service that I mentioned earlier, to actually pull those password hashes. And I configured delegation for this server, which I compromised, for LDAP on a domain controller. So then what I did, using magic, I said, this service account is authenticated to me, domain controller, I need a service ticket for this service account, using delegation, to this LDAP service on this domain controller, which the domain controller happily gave to me because I have the right to have it. So now, through Kerberos magic, I own the domain. So you can discover all Kerberos delegation. By the way, all of these slides will be available on adsecurity.org, including this one, which basically tells you how to find Kerberos delegation. You can find unconstrained, constrained, and constrained protocol transition. I highly recommend you do it. Understand how Kerberos delegation is configured, and really ask the question why. I have found hundreds of systems with Kerberos delegation enabled, and no one can tell me why, because at some point it was set up in the past. So how do we mitigate this? The mitigation is actually pretty simple. You set account is sensitive and cannot be delegated on all admin accounts, and then the Kerberos delegation does not work for those. The problem is that service accounts typically cannot have this configured. In fact, Microsoft says do not configure this on service accounts because oftentimes they need to do some delegation. Even better than that is adding these admin accounts to protected users group. And that way delegation is blocked and a lot of insecure or well-known attacks, insecure methods or well-known attacks aren't going to work the same way they did. And you can also check this here. There it is. MSDS allowed to delegate to, the list of spins for constrained delegation. You definitely want to check for domain controller spins in that setting, because that will highlight if someone's using protocol transition or something like that to LDAP on a domain controller. So when we look at attacker capability and mitigations with Active Directory, what are we looking at? Well, ultimately, what do attackers require? They need account, credentials, they need rights, privileges, and they need some sort of access, the ability to connect and do what they need to do. So three things. What do you think happens if we block one of these, or mitigate one of these, or prevent one of these? They can't do what they need to. They can have the account and rights, but if they can't connect to the services or servers that enable them to use those rights, they can't do anything. Or if they have the account credentials and the access, but that account currently doesn't have those rights, they can't do anything. Because in a traditional AD administration environment, all admins are domain admins, administration from anywhere, need a service account with AD rights, guess what? You get domain admin. Need to manage user accounts, we're going to go ahead and set up account operators. If you need to do any kind of backup operators, even for workstations, and management just everywhere, patching everywhere, agents all over the place. And compromise is very likely. So the question a lot of the times is, as an attacker, do I need domain admin? Anyone know? No, absolutely not. Attackers have lots of options. Group policy, delegated permissions, AD permissions, improper group nesting, over-permissioned accounts, service account access, Kerberos delegation, password vaults that are improperly managed and protected, the backup process, the backup service account, etc. But in the real world, these rights are everywhere. They're all over the place. Why? Because workstation admins have full rights to workstations, server admins have full right to servers, local admin accounts and passwords are often the same. Temporary admin groups, I'm going to add you to this group temporarily just for today, fix what you need to. I get busy, I got to go do something over here, and I forget about it, right? It happens. People are busy. And then the one that we see a lot is this group policy reuse. So group policy is configured with server policy on the server's OU, and someone goes, you know what, domain controllers are servers too, I'm going to apply that to domain controllers. But this policy has a restricted group which adds server admins to the local administrators group. But Sean, domain controllers don't have a local administrators group. You're right, they don't. So it goes to the domain administrators group about 5 minutes later when the domain controller applies group policy. So we worked with organizations, and they are quite confused when we point this out and say, hey, why is server admins in your domain administrators group? Like, I don't know. And then we track it back to this policy, which shouldn't have been there in the first place. Or, similarly, someone has done this, and this server policy, group policy here, has delegation to a very broad group policy management group, which has all sorts of users in it. And they have the ability to modify this group policy, which applies to a domain controller. So from the red team's perspective, they're pretty much riding a Raptor on a great white with a rocket-propelled grenade launcher, right? It's basically, they can do whatever they want because it's too easy. 80 is only secure as the admin accounts, the Active Directory admin accounts. And since these domain admin accounts are logged onto everywhere, they're very easy to find because they know the account right is a combination of the group membership, which is the 80 group and the local computer groups, and then the delegated OU and GPO permissions. So if you compromise the correct account, you have everything. And then there's the concept of admin servers. So many organizations, they're 80 admins log on to their regular user workstation with their user account, and then they RDP to an admin server, and they do what they need to do there. But the thing that's often forgotten about is that when all these admins are logging on to this admin server, often with admin rights, interesting things can happen. Even if they use two-factor to the RDP service or access protocol, WMI is missed, WinRM is missed. There's other ways to access that server remotely. So if you can compromise this admin server, you can obviously own the domain because all of these accounts are on there. So there's an interesting way to hijack this. So if you compromise an admin account, connect to that server, get system on it, and run tscon.exe as system, you can do something very interesting. Because if you can run tscon.exe as a system user, you can connect to any of these RDP sessions without a password. And so Alexander Korsnikov did a blog post about this over the summer, and he said, you know what's interesting about this? You could actually create a service that would do this automatically for you because RDP sessions to a server are shared. That's a shared environment. And so what he figured out is you could leverage the sticky keys persistence method, connect to that RDP server, hit shift 5 times, get a command prompt that pops up as system, and then run tscon there and then connect to whatever session he wanted to without authenticating at all. Now, of course, he needs prior access to that server in order to replace the sticky keys executable with cmd.exe, and then turn off NLA to that RDP server. But who's monitoring for that? So Microsoft has provided a number of Active Directory security guidance. And so they basically said, hey, we can help you with this. So let's talk about this. I'm going to go over this fairly quickly and just highlight some things and provide some additional recommendations. So stage 1, they say make sure you have a user account and an admin account. And your user account logs on to the regular workstation, user workstation, and your admin account logs on to a privileged access workstation, or a PAW. Then you want to make sure you randomize and ensure that the passwords are unique for all workstations and all servers. Makes sense. Stage 2, time-bound privileges. So ideally, your admins aren't always members of the admin group that give them those rights. You're here at the conference. If you're an admin, you don't necessarily need those rights right now. You might need those rights later. So that's the way that works, using multi-factor authentication. So I'm going to add an update to this. If you have a cloud admin account, you want to make sure that they're using an admin workstation or system to protect that cloud admin account, because access to that cloud admin account gives access to all of the cloud services that you have. So Microsoft highlights lower attack surface of domains and DCs, but there's a number of things that I found were missing to this. So clear guidance on recommended GPO security settings beyond the default, locking down protocols, features, etc. Implementation guidance for limiting this, and then locking down and controlling the management protocols to the domain controllers. Not everyone in the organization needs a WMI to the domain controller or RDP to the domain controller. So you can lock that down with a host-based firewall or some other rules. I have some more information on this at the bottom under securing domain controllers to improve Active Directory security on AD security. Then Microsoft talks about how to use Hyper-V to do all this extra security stuff. boils down to two things. Virtualization platform admins have full rights to your virtual DCs. You need to include them as effective domain admins, or leverage a virtual platform that can enable you to protect your virtual DCs from those virtual admins. VMware has a solution, Hyper-V 2016 has a solution. Second part that's important is ensuring that you have some sort of full volume encryption on your DCs, especially if they're virtual. So something like BitLocker does require virtual TPM or something along that level. So attack detection, Microsoft says buy ATA, Advanced Threat Analytics. Let's be a little more practical. Logon types, log 4624s, 0, 4, 5, 9, and 10. This will get you a lot of really good information about what attackers are doing in your environment. The other one, and again, I'm going through this a little more quickly. The slides are on adsecurity.org. There's a number of event IDs that you can get off of all Windows systems that give you insight into what attackers are doing. Attackers love installing new services. They love scheduling tasks. These things, monitoring for them, pulling these events into your SIEM will give you great insight. Domain controllers. We want to make sure that Active Directory events are logged on domain controllers. Otherwise, you're missing a lot. So there's an attack method called password spraying, where the attacker basically takes a list of passwords, starts with the top one, like summer 2018 in the US is very popular, or winter 2018, and takes that one password and attempts to authenticate as every user in Active Directory with that one password. And they do this as many times as they want to, up until the account lockout policy says that all of those would get locked out. The thing is that many organizations have bad password logging configured on their domain controllers. But if the attacker shifts to Kerberos for that authentication, most organizations do not have the Kerberos Authentication Service 4771 event ID logged. And you have to look for failure code 0x18 just to see that that means bad password. So you can detect password spraying, but you've got to do it on both sides. Then there's an attack method called Kerberosting, which is basically requesting a service ticket for a service principal name associated with a user account in AD. So that's just basically a service account to support Kerberos auth in the environment. We can request that service ticket with RC4 encryption. I remember before I said Microsoft has a lot of compatibility. Well, they decided instead of coming up with a new key for Kerberos, they would use the NTLM password hash for it. So this service ticket that we request with RC4 is encrypted by that service account's NTLM password hash, which means we just have to request it, take it offline, put it on our password cracking box, and when we're able to open up that service ticket, we have cracked that password offline. And we have about as much time as it takes for that organization to actually change their service account passwords, which is usually never. We can monitor for this. We can detect this by setting and monitoring 4769s with these ticket options and this ticket encryption, which is RC4. So stage 3 is a little bit bigger, more long-term. Microsoft has here. So you want to look at the roles and rights in your environment. Plain English or German, as the case may be. What do you do? What are the rights that you need? Okay, let me translate those to the system. Reevaluate, redefine, and reestablish. So Microsoft has this tiered model, which whenever I talk to customers about, their eyes glaze over. Why? Because in the admin tier model, all domain controllers and domain admins go into tier 0, all server admins and servers go into tier 1, and all workstation and workstation admins go to tier 2. Microsoft's been talking about this for a couple of years. And then never the twain shall meet. Tier 1 can't go into tier 0, tier 2 not into tier 1 not into tier 0 nowhere else, right? Separate those tiers. What does this mean? This is where I lose pretty much everyone at the customer site because they're like, there's no way we can do that because you're saying that we need to duplicate what we have already for management and patching for that tier 0 and admin workstations, and then we need to make sure domain controllers and ADFS and all this other stuff are in that tier and protected. And we have to do the exact same thing for tier 1 and separate management and patching in there and separate admins, and we can't reuse those admin accounts. We can't reuse those admin workstations. And then we do it again for tier 2 with all these workstations and workstation admins and everything else, and I can't do that. So takeaway for today is, if you're going to focus on anything, just focus on tier 0. Protect your domain admins, protect those systems that are the most critical, that have those most critical password and credential information. Because once an attacker gets those, it's game over. And at some point later on, at least look at and figure out a way to limit access at each of these other tiers. Because ultimately, there's things missing from this whole tier model. Removing local admin rights from users, which is important. Limiting broad system admin, like the system access, like workstation admins, server admins. And then having host-based firewalls to prevent any computer to connect to any other computer. And then practical guidance on achieving these tiers. I'm giving you that now. Focus on tier 0. And of course, there's service count risks that have access to everything. Most organizations have a service count that does some sort of vulnerability scanning. Unfortunately, it's usually just one service count for everything. So at least, say, a vulnerability scanning account for domain controllers, which is only active when they need to scan. Another one for servers, another one for workstations. Take this tiered model to the level where it's practical and possible in your organization. Make progress with it. And then finally, Microsoft's Red Forest, or Enhanced Security Administrative Environment, where we take all of this tier 0 and put it into a separate forest. Microsoft touts this and highlights this as the most secure way to administer Active Directory. And it involves all this. Basically, we're going to use Windows Server 2016. We're going to have the separate admin forest with a special selective auth trust. So that way, only the admin groups from the admin forest can connect into our production AD and manage it, because we're going to empty all those admin groups in the production forest. We're going to make sure that they use admin workstations. We're secure and lock off and isolate this environment. We're going to do all this stuff. We're going to duplicate everything again into this environment. So there's a few problems with this. But ultimately, as part of the implementation, we have to assume breach. We have to check the production AD environment. We've got to start clean, make sure we're using clean media. Oftentimes, that means physical servers in that admin forest. And then there's a lot of questions about how this actually works and is maintainable and managed. Some of the biggest organizations are doing this. And it takes a long time for them to actually get it set up right, because there's limitations to this approach. It's very expensive. It increases management overhead and cost. You're duplicating PKI infrastructure if you have it in the first place. You're doing pretty much all physical. You're forcing the admins to go through the system and yet having more accounts. You're duplicating this infrastructure and making sure that all of this stuff is done, but it doesn't fix the production AD environment. The issues that you have today, you still have. And doesn't resolve these expansive rights over workstations and servers. And as we've already established, attackers don't need domain admin. So the best case is it does isolate AD admin accounts, which is useful, especially when you have a multi-forest environment and you have your admins in a single forest that are well protected and managed and isolated and monitored. But what about domain privileged service accounts? These are often forgotten about and missed, because you can't necessarily very easily go through and wipe all the permissions off these without fully understanding what the rights are. So that's been a lot, right? Like I said, the slides are online. But ultimately, it comes down to this, the things that matter. Making sure those local admin passwords are unique and they change. Leveraging host firewalls. I highly recommend that you enable host-based firewalls on all your workstations. That will stop lateral movement. It will mitigate most ransomware attacks that spread out through the environment from system to system. Reducing the AD admin group membership, limiting service account privileges, always good ideas. And if you take away one thing here, figure out a way to get your domain admins, your AD admins, to log on to admin workstations that are separate than the regular workstations that are managed by everything. And then there's ways to lock down and protect the environment by limiting these older protocols and features that still exist in most environments. And then control Office macros. And we have some information on that on AD security as well. There's further key recommendations here, which I will leave up after I say, that has been my time. Thank you very much for yours.
Thank you very much for this broad overview. Other questions?
Hi, so thank you for your talk and your great contributions on AD security. So it's really great. But do you personally see using AD on something below 2016 as a lost cause? Because we are like, yeah, we're deploying Sysmon, we use ESAE, pause, RC4, detection of Kerberos roasting. We bloodhound our complete forests, go like, yeah, why do you need to write the ACL on your domain admins? But it really seems like it's just making the ship sync, let's say, a little later. So
I would say you don't have to go to 2016 today or tomorrow. I think that if you have 2012 R2 on your DCs, you're doing pretty good, and all the other things you're doing are great. So yeah, I would say that the things that you're doing, from what it sounds like, are the important things. Continue to focus on AD as the service and the infrastructure and protecting that, and kind of locking that down. We work with customers that have hundreds, if not 1,000 domain controllers, and obviously getting up to 2016 is a very long process for them. So absolutely, there's other things that you can focus on and really work on before getting to that, depending on the size of your organization. So I wouldn't necessarily say a lost cause. But.
More questions? So Sean, thank you very much again for your great talk.
Thank you.